shit doesn't work. It never worked. It never works. It's always brittle, it's always broken, it's always slow, and it's totally not worth it. That realization took even longer to arrive at than fumbling around with Docker. But finally, last year, we merged this pull request for Hey. Hey had a lot of system tests, and they took a long time to run, and developers were constantly battling how to make them stable, and we said, enough. What if we just nuke the whole thing from orbit? It's the only way to be sure, and leave only 10 system tests left as a smoke path of just does the whole thing work. Don't use it to test anything in depth. And I've never heard of a single bug we pushed to production in Hey that this shit would have caught. It was not worth it. Therefore, we are yanking the recommendation in Rails 8.1 that all new controllers should have system tests. We are no longer going to be generating them. The framework is still in there. I think it can make sense for smoke tests in a very small proportion, but for us, it was absolutely not worth the trade-off otherwise. And these are some of the realizations I think are really important to have. That you go in a new domain, a new territory, and think, this is gonna be great. And then when it's not great, you go back into the little hedge and say, like, system tests? No. Speaking of tests, do you know what really pissed me off as we were getting out of the cloud? It was this fucking thing. The Cloud Test Runner. This is small text, so I'll read it for you. This was a test run on BCX, the second version of Basecamp that we're still running. A relatively small app, smaller than Hey, smaller than Basecamp 3. It took 10 fucking minutes to run these, and it ran it in, 8 different parallelized projects. They were all carefully set up on a cloud runner, and it took 10 minutes. Total pain in the ass, totally too long. But I didn't, what do you do? What do you, if we have a lot of tests, we have to run the tests. We can't just kill all of them. Maybe we can kill the system tests, but we're not gonna kill everything. And then I was like, you know what? That made sense in 2019. We had Intel chips in our MacBooks, and they sucked. And they basically hadn't changed for 6 years because Intel just ran into the dirt and could not figure out how to get their new node out. You had all these cloud CPUs, AMD Epics going awesome. Everything was great in the cloud. The development scene sucked. And then something magic happened. TSMC, through the grace of Apple and others, really improved the chips we have in our local developer machines. To the point that the chips, the CPUs we now have are way better and way faster than the shit we rent in the cloud. Here's the Hey test suite. The Basecamp test suite, as I just showed you, have 13,000 assertions. The Hey test suite has 30,000 assertions. I saw a cloud run for the Hey test suite that took well over 15 minutes. You can't maybe read it, but you know what the fastest one is on the fastest AMD you can buy today? 1 minute, 12 seconds. Even on an Apple chip, an M4, it's under 4 minutes. This is totally doable to run locally for even a relatively large app like Hey. And many of you have smaller apps than that, and a few of you have much bigger apps than that, and none of this shit applies to you. You're not gonna be able, to run the Shopify test suite locally. That's not happening tomorrow, but that's the 0.001% of everyone making Rails applications. The vast majority of you should be able to replicate these numbers and run your entire test suite locally. And if you do it on Linux, it's about twice as fast as doing it on a Mac. You got the M4 Max here, the fastest Apple machine I've tested, 2 minutes and 22 seconds. And right below it, you have 2 minutes and 5 seconds for my trusted framework laptop. And then you have the framework desktop at 2 minutes and 23 seconds. This is totally fast enough. You just run it locally, and you can just blow up all that complexity of running cloud runners. Now, Here comes the common objection. Well, if we allow developers to run things on their own machines, first of all, you're going to get, it works on my machine. Yeah, you think just because it fucking works in the cloud, that it works in the cloud runner? Like, that doesn't mean anything extra. What means extra is you pin down your dependencies, you pin down your versions. This is why we did the other stuff. We use the same version of the database, the Redis, the everything in Docker, and we can pin it exactly. We're not dependent on a random version in Homebrew to bail us out. We use Mies to pin exactly the version of Ruby that we're going to use. And between those two things, the Ruby version and the database versions, that's it. Any esoteric language that you, or library you might find that isn't the exact version, it's not going to fucking do anything. We've been running this setup for quite a long time. We haven't had a single issue. And if you are, weigh it against the joy it would be to know whether your PR is ready for deployment in 1 minute and 12 seconds. Now, we actually do protect the PRs so that they can't just be merged now that there's no cloud runner. We use a wonderful feature of GitHub where you can require sign-off from a past test. You can install that with a tool that we have, and when you do, it requires a human to certify that they have signed off, that they ran the test, and they all passed. This sounds like it shouldn't work, because it sounds like it depends on trust. But you know what? Trust works. In most organizations, your employees are not shitheads. They're actually programmers who want to ship working software, and they know that if they lie on the attestation here, they will get fired. It's a really effective enforcement mechanism, I'll actually say. So, not a problem. In Rails 8.1, we have baked in a way to do all of this locally, not just a test. There's a brand new DSL for declaring your local CI run, where you can run your Robocop, you can run your gem audit, and you can run all your tests, and you can do the sign-off at the edge to clear the PR from merging. When we run this locally, it takes no time at all. Let's shift gears. All this benchmarking I did with different local computers around how fast they can run your local tests and realizing, why are we paying cloud providers to run slow tests when we can run them real fast on the machines we already have, reminded me of this. This is Fortnite. Fortnite has to render an entire scene of 3D graphics 120 times a second. They have 8 milliseconds to render this fucking scene. And you're telling me it's got to take 15 minutes to pass some goddamn paper tests in the cloud? No, that's unreasonable. And when I thought about that, I thought, like, you know what? There's a lot of things that are really unreasonable. We are waiting way too damn long on way too many damn things. The example I gave at the start is a great illustration, FTP. We could deploy in 5 seconds. Now we're confident or content deploying in 15 minutes, half an hour, 3 hours, 8 days. No, no, no. We're going to solve all this. We're going to apply engineering principles, and we're going to have a frame budget for everything. And where I'm going to start is we're going to have a bootstrap budget. The idea that a new developer joining a new company should spend a few hours setting up their damn laptop is preposterous. At 37 signals, this is our bootstrap budget. In 15 minutes, you should be able to go from cold machine that has nothing on it to having everything set up and a change deployed in production. That's our budget. To make that budget happen, I listened to Alan Kay-ish. People who are really serious about software should make their own operating system. Let's do that. Let's make our own operating system. Let's do it right now. Let's see if we can be within budget. We have 5 minutes to set up Umachi from this little USB key on a brand new framework desktop. Here's the stopwatch. Let's go. I'm going to plug in the USB key. I can fiddle it in here. I'm going to turn on the machine, and I'm going to start the stopwatch. Let's go. Now, we're going to install Umachi on a brand new framework desktop, as I said. There's nothing we're going to keep for it. We're just going to blow everything away. This is a project I was about to say spent the last 2 months about. That's not true. Obsessed the last 2 months about. Let my life be consumed entirely by a Linux god for the last 2 months, as I've dived into the idea that it should not take hours to set up a new machine. And also, I should not have to ask Apple for fucking permission about anything at all. So we're gonna set up this machine. I'm going to enter my username. I'm gonna give it a big quick password here. I don't need to enter the name or email address. The host name, we just do Amachi. We are in Amsterdam, that's true. Everything looks good. And we're gonna install it on the internal NVMe drive. Yeah, we're gonna blow it away. Let's go. So as this thing is installing, let me tell you a little bit about Amachi. I switched to Linux about 18 months ago, and I did what everyone else does when they switch to Linux. I used Ubuntu. That is the most popular Linux distribution. It's really nice. Canonical did a great job at putting a Linux distribution together that will not be too foreign or too scary for someone moving over from Mac. That's exactly what I needed at that time. Something vaguely familiar, but built on the underpinnings of Linux. And I had a really good time for about a year, tinkering with that and changing things. And then I saw a YouTube video. And the bastard who made it and dragged me into this obsession is actually sitting right over there. It is Mr. Typecraft himself, who dragged me into the mysterious world of Linux ricing and tiling window managers and Hyperland in particular. And what I found was like tumbling down the rabbit hole. What even is this place? What do you mean I'm not using a mouse to move windows around anymore? What do you mean everything just resizes when I open things? And why does it look so good? Why does it look so magical? And why is everything a TUI, a terminal user interface? Wasn't that shit we gave up in the 80s? And then I thought, oh, the 80s. I like the 80s. I remember the 80s. They were cool. I remember the 90s when I was on the Amiga and running a BBS. And we had cool ASCII graphics. Oh, like that. That's like the 90s. I remember BBSs. They were really fun. What if computers were fun again? Wouldn't that be great? Yes, it would be great. Computers should be fun. They should be cool. They should look a little bit like a hacker movie. That's actually an aesthetic that's worth aspiring to. And what if we built an entire operating system in that image, in those cool vibes, in that cool aesthetic? Oh, and also, built on fucking Linux, the operating system that runs 95% of every server in the world that drives the web. The system that has been optimized by a Finnish lunatic with a foul mouth for the last 34 years. Yeah, that's the system actually I would like to run. That guy is obsessed. And that obsession has produced the greatest open source project of all time. Linux is truly amazing. I've been running Linux for 30 years on the server, and I've totally been sleeping on the fact that you can actually run it on your computer too, and it's gotten really damn good. Now I know a lot of you out there tried some version of Linux at some time, and you couldn't get your fucking Wi-Fi to work, or your printer wouldn't print, or any of the other anecdotes that everyone who's ever tried Linux in the last 30 years will have like a Rolodex of. Do you know what? First, I will say this. Almost all of it has been fixed. Do you know what? This is what happens if you just keep working on a problem for 34 fucking years. It ends up being really good in the end if you're that obsessed. We've seen it with Ruby. When I started using Ruby, it was version 1.6.8. Do you know how much faster, how much better, how much more featureful Ruby is today? Of course, oh shit, we're done? Are you kidding me? That's not even 5 minutes. That's 4 minutes and 44 seconds. And then I just gotta unplug this thing. Whoa, that's pretty fast. Things get good if obsessed people keep working on them, especially open source, especially if you can gather up an entire community of people who are as interested as you are in making technology better. This is why open source is winning in every domain that we care about when it comes to web development. Do you buy editors anymore? Do you buy databases? Do you buy web frameworks? No, you don't. You use open source ones that if they don't do as you like, you just fucking change them. Isn't that amazing? Oh, here's Omachi. Hello. Let's make a Rails app. Because this, of course, has everything you need to make a damn Rails app within the first 5 minutes of booting this ship. So we're going to hop in here. We're going to do Rails new blog. Of course, it's going to be a blog. Not a blog in 15 minutes, but a blog in 5 seconds. And when we start this, we also realized, you know what, this is still a little bit of work in progress. And if you run it on a low-resolution screen like this, you're going to have to hop into a config file and change that a little bit. But does that matter? Are you afraid of a little config? No, you're not afraid of a little config. You're actually excited when you see NeoVim pop up and like, oh, that's what all the cool kids use. Can I do it too? Yes, you can. It's free. So we're going to do this. We now have our Rails application here as a blog. We're going to generate R, by the way, because of course this has the aliases built in that I love to use. Just R, not Rails, not bin Rails, just R. R, generate, scaffold, post, title string. We got that going. Then we need to migrate the database. And then we need to start it just on dev. And when we do this, we can hop over here. Oh, hello, Rails. Hello, Rails. Hello, Rails. Hello, Rails. Oh, isn't that nice? That's a nice air screen. And here's the real thing. Hello, world, with a brand new OS in about 6.5 minutes. And not only just like hello, world, but fucking cool hello world that can change it to green. Like, what about that, huh? Like, whoa, look at those windows. What if shit just looked so cool everywhere? What if you had like a screensaver that was like the 90s? Wouldn't that be amazing? That is Omachi. I've been dedicating the last 2 months on it. I'm going to make it the damn best way to develop Ruby on Rails on it. And I hope you will give it a go, check it out, even if you love your Mac. We actually have 200 USB keys with Omachi on it out at the Basecamp 37 Signals booth if you are serious about installing it. And before you get that key, it cost me $7. So I will look you straight in the eye and say, are you going to actually install it? I'm not giving you a fucking souvenir here. So this is for people who actually want to install it. Come out and see us at the booth. So let's get back to the presentation. Here are my backup slides in case the live demo blew up. It didn't, so we don't need them. Isn't that nice? I like when things work out. The great thing about making your own damn operating system is you can put in all the stuff you want. I'll give you just one quick example here. Omachi ships with Git, it ships with Mies, it ships with Docker, it ships with databases, it ships with everything a web developer would ever want. And let's dive into just one example, Git. So it ships with Lazy Git, which is an amazing TUI for managing your Git interactions. This is running inside of NeoVim. I used to use the GitHub desktop app. Nice app, not a TUI. This is much nicer, this is much quicker. I cannot believe that this project existed for years and I didn't use it. We set up common aliases, like that R you saw. We can set up common aliases for all the Git operations. We can even pre-configure your username and your email address such that your commits will actually work out of the box right away. We pick those out of the sign-up form. We can do everything. We can set up those aliases, as I said. We can have a nice Starship prompt out of the box that will tell you if you have any new files in the repo that are dirty and you need to check in. We can just do everything. We can do everything because it's ours. And we don't have to fucking beg Apple for a crumb. No. We can have a loaf of bread the size of your head. And then we can realize we don't have to stop there. After creating Omachi, I realized, actually, why isn't the entire setup of a new machine at 37 Signals exactly like this? It should be. So we've created a tailoring script that installs everything on the setup in just a few minutes, checks everything out. The developer is ready to use. As I said on that budget, we want to deploy in 3 minutes. That sounds crazy to a lot of people who might be spending hours, if not days. But here's a deploy of Fizzy, the new project we're working on. You can see it up in the corner, 58 seconds. We can make this so much faster, running local CI, deploying everything. Although I will say, this is Basecamp 4, a few more servers. It takes about 4 minutes. I know, sad little dog. I'm a little ashamed of it too. We will shave off that minute and get down to 3 minutes, I guarantee it. And we will get back to this. We will get back to a way of developing that feels way more like 99, that feels like it's free of needless complexity, and we will move much faster. And then when we deploy things, a little aside here. I've gotten really into these little mini PCs, and it's really amazing just how much performance you can crack into these boxes. These stacks here have 76 cores, and I think about 300 gigabytes of RAM. It's pretty cool. I took one of those boxes, and do you know what this campfire you guys have been using all week? Yeah, it runs in my closet. On literally that fucking machine. That's not stock photo. That's me in my dirty utility closet, taking a picture of the machine that runs Campfire for everyone here and barely breaks a sweat. Oh, and it's $300. And do you know how much that would cost if I ran it in the cloud? Oh, here's a droplet. Oh shit, that amount of performance would be $300 a month. And I mean, I know really this is bad, and this is just in jest. I know they're out there. Heroku. This would cost like upwards of $1,200 a month to run this amount of performance that $300 runs in my closet. Do you know what? You can just do things. And this gave me an idea. And the idea was, if this amount of performance is available to mere humans for hundreds of dollars, what could we do at an enterprise level? We've been running 2 main data centers for 37 Signals for many years, and we just created an outpost in Amsterdam, actually in Amsterdam, right here. We have some Hay servers standing right here, so if you're using Hay in Amsterdam, it's going to be pretty fucking fast. But what if we went further? What if instead of having these mega data centers, we had micro data centers? What if it looked more like my utility closet than it did like this big honking thing? So as I said a few times, we're working on a new product called Fizzy, and whenever I work on a new product, I want to push the boundaries. Sometimes that aligns very well with something that's good for the product, other times that's just hella fun. And one of the boundaries I wanted to push was this idea that the internet just like packages fly around the world and is super fast. Because you know what? Packages over fiber, they fly at the speed of light. Little light bouncing inside of these glass cables, and it's about 300 million meters per second. Well, what was this math? I made this math like 4 days ago. The point of the math was, the circumference of the Earth. The circumference of the Earth is 40 million meters. If you divide those two things, you have the theoretical time it takes for light to travel one time around the globe. It's 137 milliseconds. And that should kind of be the theoretical boundaries for packages as they ship around. Well, it takes a little longer, because not all the cables go straight around the Earth, and not all the light goes in a straight line. It actually bounces inside of these cables. So when you actually measure it computer to computer, this is about how long it takes. New York to LA, RTT is 70 milliseconds. If you get all the way from New York to Sydney, it's 220 to send one package and get a return. That's a lot of time. You guys have probably been looking at your performance charts for how long your X run times are. 220 milliseconds, for a lot of people, that's their budget. And you just blew it on a single fucking package. And you don't get to send one package. When you're making a post request and it's the first one, first you've got to do a TLS handshake. Oh, well, that's a package. And that's even highly optimized. It used to be like 2 or 3 packages. Now we got it down to 1 package, but 220 milliseconds. You post something to that, you get a response back with the location of where the browser should go to next, 220 milliseconds. You do a new GET request to get to that location, 220 milliseconds. New York to Sydney on one post have spent almost 700 milliseconds just on the lag of light. If you do that experiment in other locations, if you do New York to LA, it's still pretty damn meaningful, because these are long distances. America is actually a pretty big country. There's like 210 milliseconds here of just light lag going back and forth between New York and LA. But I made some other tests too. What if you move things a little closer? I'm in Copenhagen at the moment. When I ping my local Copenhagen website, that is literally down the street, it's 2 milliseconds. That's pretty quick. Even when I travel the entire country, it's 8 milliseconds. When I go to Falkenstein, where Hetzner has a data center in Germany, it's 17 milliseconds. And when I go all the way here, it's 25 milliseconds. Oh, that's actually not that bad. And when we add that up, the lag of light on all of these connections is way less. 660 milliseconds from New York to Sydney, 6 milliseconds if I could just stay inside of Copenhagen. That's a huge speed upgrade. Now, if you make an entire actual request here, you say your X runtime on the server for a post is 150 milliseconds and your get is 75 milliseconds. The entire operation of making that new post, New York to Sydney, is almost a second. Copenhagen to Copenhagen, 200 milliseconds, a little more than that. Do you know what else is about 200 milliseconds? A Formula One driver's reaction time when all the lights go out. That's what we should target. That should be the goal. That we do not exceed the response time of a Formula One driver. How do we do that? We chase the white rabbit that the cloud industry has been chasing for a decade plus. Edge computing. And I saw a funny tweet this morning from Peter Levels saying, edge computing is all bullshit and no one has made it work yet. And you know what? I'm inclined to agree, but it also sounds like a fun challenge. If no one else can figure it out, let's figure it out. And the way we are going to try to figure it out with Fizzy is with this pattern of many small outposts. Essentially the idea of the server in the closet being so cheap, couldn't we just have a lot of them? Yes, we could. But the first thing we need to do is we need to ensure that every data center we stand up does not need the entire beefy database that we need for every single customer and running that for Basecamp. Hey, that's what makes it expensive. It's actually the data, it's not the compute. Because once you start subdividing your users, you will have less need for compute in that area, but you still need the whole database. No, what we need instead is for every database to store store everything, all the data, but only serve a fraction of the queries. If we could do that, if we can accomplish that, we could have mini data centers everywhere. We could have these little drops everywhere if we didn't need all that complicated infrastructure. For Fizzy, we could maybe have it everywhere here. And if we put Fizzy in all of these cities I have on this list, almost all customers would be within 25 milliseconds of an outpost, and their response times would feel a lot faster. So to make that happen, we have moved heaven and earth. The first piece of earth we've moved is in a project called Active Record Tenanting. Because to make this whole setup work, we need to blow up the single database for everyone and turn it into one database per customer such that we can put the database next to the customer or as close as we can to it. That has required an enormous amount of digging inside of the internals of Active Record and a million other frameworks. Mike has been working on this. We're going to push it out. There's been a few updates already resolved, but the fundamental idea is creating tenants. And tenants is one database to one customer and being able to flow all that through it. Not only does that have benefits for performance, it also has benefits for isolation, for backup, for privacy, for a million other reasons, and now you can place these databases around the world. But when you do, and you place all these databases around the world, you need to sync them. That's the hard part. And to do that, we have spawned another project that Kevin has been working on and we'll be talking about later today, which is Beamer. And Beamer is a simple way of replicating SQLite databases, which is what we're using for this project. You could use MySQL too, but I think SQLite is uniquely suited for the idea that every customer should have their own database. This setup keeps it in replication. If that sounds vaguely like LiteFS, it's because it sort of is, but it's built for an entirely different scale. It's built for tens of thousands of individual databases per customers. It's built for tens of thousands of transactions per second. Because we're not just replicating 1, 2, or 100 databases. We're replicating one for every customer. And then finally, we need a way to route all of these things around the internet so that people land on an outpost that's near them. We've extended Kamal proxy, adding in this geo component such that we can get a setup that looks like this, that you might have databases in the US and you might have them in Europe. And if you're hitting a customer who's in the US on a get, you can either get routed based on geo-routing to the app server in Copenhagen and the one in US East. That's all the readers. The readers are safe to access from anywhere, but we still have a dominant writer. That's the hard problem. We're not solving all of the distributed writers yet. But when you do that, you're redirected to the right writer. To make all that happen, we need to go back to that magical year of 1999, where everyone knew everything and designed everything with perfect foresight for all of the internet. This is from RFC 2616 that defines the HTTP 1.1 protocol. And what does it tell us? It tells us that get and het methods should not have the significance of taking action other than retrieval. Which is a really long way of saying don't fucking write when you're doing a get. That blows the whole thing up. So we are going to restrict all writes only to happen on posts, and the other methods we piggyback off post. And when you do that, you get the wisdom from 1999 forward, and you can make all this whole thing work. Finally, we use session affinity, of course, because if you do a write to a writer, you can get a stale read. If you're sent to a reader that doesn't yet have the updates, the standard way of doing this is just kind of putting a finger in the air and saying like, I think in like a second, it's probably okay. That's a really poor way of doing it because it means when you write that comment, you're very often redirected to the read for that comment back on the writer, which may be far from you. You want to get redirected onto the reader as soon as the reader is ready. If you run a really fast replication and you have this technique of doing it, you can do that. So instead of just taking a static number 1 second, we will boil it down to a transaction ID. And if that transaction ID, what we have written into the database, is available on the reader, we're good to go. And if we're not good to go and the reader will know this, we will return a header that will redirect you somewhere else. All right, that's our gift exchange. It's full of more. It's action job continuations in Rails 8.1. It's Action Native Push out in beta right now. It's Turbo Offline dropping very soon. It's Hotwire Native 1.3. Go see the keynote at the end of the day. It's Action Text Lexi, which is shipping today in beta. It's Active Record Tenanting that we still need to wrap up. So too with Beamer and Kamal GeoProxy. It's less. It's the idea that you can just run native Ruby and Docker DBs. It's the fact that you can use local host for all your development. It's the realization that we need system tests, that we can run our testing locally, that we can do scripted setups, that we can have a new computer ready in 15 minutes, that we can deploy from local. That's a lot of stuff. Some of the good stuff is shipping in Rails 8.1 right now, after this keynote. That's Raphael. He's the release manager. He's going to push this out. I invite you to check out Omachi, check out Linux, update your quite possibly ancient ideas of what Linux is, works, or what it could look like. I invite all of us to do more end-to-end problem solving, to do more end-to-end open source, not to accept that there are parts of our stacks, whether it's the computer or the server or the framework, where we can't just change shit if we want to change it. We should be able to change everything. We should own everything. Because we want end-to-end freedom. We don't want people telling us what to do. I don't want people telling us what to do. I certainly don't want Apple telling me what to do, or what I can do, or where I can be, or what I can distribute. Fuck Apple. I want libertas, I want proprietas, I want pietas. I want freedom, ownership, and duty. And what you do with those virtues, well, that's up to you, isn't it? Thank you so much.